In the previous videos, we talked about how to write out acid-base reactions and how to determine which species in a reaction will act as the acid or the base. But how do you know the reaction will occur? This is where the leveling effect becomes important. The leveling effect restricts the use of certain solvents with certain acids and bases. Before we continue, I'll describe the leveling effect as it's described in textbooks. However, I find this definition confusing, so I'll instead give you a trick to be able to solve problems and choose solvents while keeping the leveling effect in mind. The leveling effect describes the idea that an acid of a reaction can react with a solvent, and the base of a reaction can also react with a solvent. Because of this, the actual acidity or basicity of a substance in a reaction is more dependent on the solvent, because the solvent itself begins to act as the acid or the base. We need to be careful when setting up or choosing a solvent for the acid-base reaction. You need to be aware that the solvent cannot be a stronger acid than the given acid of the reaction. This is because when the reaction occurs, the solvent ends up reacting with the base instead of the given base. Also, the solvent cannot be a stronger base than the given base. Similarly, when the reaction occurs, the solvent will end up reacting with the acid instead of the given base. A cool trick to remember is that the solvent must be in the middle of the acid and base in strength. The easiest way to determine if a solvent is in the middle is to use Oreo rules. If you aren't familiar with Oreo, make sure to check my previous video on acid-base strength. However, even if we were to use the right solvent for our reaction, sometimes the reaction may not go to completion. To understand this, you need to keep in mind that for a reaction to work, we need to have products, not reactants. If our acid and base are weaker than the conjugate acid and base formed, then the products will react right back into our original acid and base. Therefore, when we draw a reaction, we need to compare both sides. The acid on the left must be stronger than the conjugate acid on the right. The base on the left must be stronger than the conjugate base on the right. This summarizes our rules for creating and determining reactions. You'll be expected to employ all the concepts learned in this past unit to create acid-base reactions. To practice, try the worksheets linked below and watch the explainer video for it to check your work.